Okay, let me get started. Let's see, first, some reminders, let's see. Participation quiz number 5, and answer that one by the end of today. And quiz 2 on Thursday, the take home. Assignment 3, due tomorrow, at the end of tomorrow. And project 1, we're done with that one, alright. Okay, one favor I need to ask of you for project 1, maybe I should put that in here. Probably should have mentioned it here. How to turn it in. So you got the notes on how to turn it in. Run the submit.cs370 or submit.SE-370 command. You might need you to run that again. Those two, either one of those commands, because otherwise I may not see it.
So should we do that with all submissions or just the project?
I think you should do it for all submissions, actually.
Does that?
I thought it would take care of all the future submissions, but
So does that handle all the subdirectories, or does it handle only the current working directory?
It'll handle the work directory plus, it'll handle the CS370 or SE-370 directory and all subdirectories. All files and subdirectories under your course directory will be made available to me. Because apparently it doesn't work quite as I expected. I thought all future files and directories created would be available to me, but seems like it's only 50% effective.
So then we can write it in any directory is what you're saying.
Let's see. Yeah, you can run it anywhere. Doesn't matter where you run this. The idea with those shell scripts is that it's supposed to make your files and directories available to me under your CS370 directory. So yeah, if you want to look at it, this is what it looks like. So it's supposed to work inside your course num directory, CS370 or SE370. Does not matter where you run it from. So you have to do a little bit extra work there. Run these two commands. So that's the first project, and there should be a second project soon, but that'll be the last project. So only 2 projects for this semester. We're scaling it back, which means I'm going to have to update the syllabus as well to reflect that. Now let's go back and look at file and network and revision control utilities. Okay, we went through all of this. rsync wget. Let's look at the diff and patch. So the diff utility is it's a technically, yeah, it's a text utility, although it's not much of a text processing utility. So its distinction is that it finds differences between 2 files. And I don't know what this is supposed to be. I don't know if this actually works. it does. Okay. Thankfully it does. So we're going to follow these directions, and it's going to be downloading some files related to this in a compressed format. So we'll create the directory examples rev control first. Here. First command. And then we'll change to that directory, rev control directory. We're going to apply this wget command here. This will download to your current directory the diffpatch.tar.xz archive. You'll do that quietly with wget's quiet option. So it'll be saved as this diffpatch.tar.xz. So you should have that file there now. That's what it looks like. Very small tar.xz archive. And then to extract from that archive, we will extract a diffpatch directory using this tar extraction command. Several options in here, but X means extract from this file here. Do it verbosely. This is telling tar that the file is going to be XZ compressed. And the F precedes the name of the actual archive file. And all we're doing there is creating a diffpatch directory with 4 input files, or 4 files, SUS1, 2, 3, and 4. And we run these commands. So you should have a diffpatch directory that will change to now with our 4 files. So there they are. What do they look like? We'll cat them all together and see what they look like. So it's actually 4 files here. That's what happens if you do a cat and then you use the file globbing syntax SUS and an asterisk. You see the contents of all 4 files, but you cannot tell what contents belong to what file because they've all been globbed together into a single standard output from cat. If I wanted to see the contents of the individual files, what could I do? Let's see. Several options for that. I can go find SUS, or just, yeah, all right, find SUS. No. Starting at find, I'm gonna try its exec option to, I'm not gonna echo. Maybe I can echo. See, stuff like that does not work with find. So this is where the limit, okay, run into some limits with find. So this is where I find that I really have to use a for loop of some kind. For file in so I'm using the file for loop with my list is gonna be the list of files that begin SUS. So SUS asterisk here. Running this for loop. This is gonna take, this file variable is gonna take on the names of the 4 SUS files, SUS1 through SUS4. I'm going to echo the name of the file, then semicolon, I'm going to cat each file. So what I've created here is I'm doing these two things inside the body of my for loop. I'm echoing each file and I'm going to cat each file. So this was the command down here. So what I end up with, I see the name of the file, I see its contents. I see the name of the file and see its contents. Name of file, see its contents, and so on. So in some cases, I gotta use a for loop, a quick for loop of this type to do that. Anyway, those are the 4 files we're working with. Now we look at the diff command. So the diff command compares 2 files and displays a list of editing changes that would convert the first file into the second file. A list of changes. That, in other words, it shows you the differences between the 2 files. Where the 3 kinds of editing changes that would convert the first file into the second file are addition, change, and delete. So the diff utility is actually the functionality of the diff utility is used a lot actually. The similar functionality to the diff utility. So if has anybody ever edited a Wikipedia article? You have, all right. Let's look at, so here's a regular expression article on Wikipedia, and if you view the history of this article, can I do that? And I look at this revision of it. Let's see if it's, that's the current revision. Okay, that's the current revision right there. There's actually a diff link here. And if you look at that, it gives you the differences between versions, or differences between revisions, and shows you how they're different. Also the type of differences they are. And so the diff utility is, that's the basic idea. It's trying to give you the differences between revisions of a file. And the 3 types of addition, or 3 types of differences it knows about, are the addition of lines, the changing of lines, and the deletion of lines. So diff, in its basic form, goes diff, and then some from file, and then a to file. From file versus to file. And you can use various options for that. So we'll look at differences between file 1 and file 2. File 1 being saved as SUS1, and then file 2 is saved as SUS2. Okay, so if you look at the differences between the 2, they're kind of similar. If you look at them, there are minor differences between the 2. In order to see the differences, I'm going to look at the results of this command right here, diff. SUS1 versus SUS2. And it looks like there are differences in line 1, and line 3 for those 2 files. The arrows here indicate this line belongs to SUS1, and this arrow indicates this line belongs to SUS2. That's how they differ. So the idea with the diff utility is how would you what changes would you have to make to this in order to make it this? Okay. What changes would have to be made to convert the first file into the second file? So that's what we're seeing here. So difference here at line 1 means that a change would have to be made to line 1 of SUS1 in order to make it into SUS2. And there's also a difference on line 3. Okay, and so on the left arrow means SUS1. In SUS1 we have this line 3 and the access of the memory make sure floppy disk abort. And this arrow means this is what line 3 looks like on SUS2. And the access of the memory make sure floppy abort. So this means the second character here means this is a change type of difference. You'd have to change line 1 of the left file, and you'd have, in order to make it the same as line 1 of SUS2. So C here means a change would have to be made on the line. The entire line would have to be changed to make the left file the same as the right file. Now let's look at file number 3, which is SUS3, which is actually 2 paragraphs long. And so if we look at the difference between 2 and 3, diff between 2 and 3, it looks like this. So here, the only change required would be an addition starting at line 4. And you want to add lines 5 to 9 of the right file. So that's how you would make the 2 files equivalent. You would make SUS2 into SUS3 by adding after line 4 lines 5 to 9 of the second file. So this is the second paragraph of SUS3. So this is a different type of change that the diff utility sees when you compare these 2 files right here. And the significance of 5, 9 is the range of lines. Add lines 5 to 9. If you look at the difference between SUS3 and SUS4, so SUS4 is again only a single paragraph, this paragraph right here. And we know that SUS3 contains 2 paragraphs. Now if we're looking at the difference between those two, we're going to see it's more than an addition that's needed. So SUS3 versus SUS4, diff. If we're comparing those 2 files, okay, so we've got, let's see. Remember, SUS3 is the one that has 2 paragraphs. SUS4 is the one that has only a single paragraph. In order to make SUS3 the same as SUS4, the 2 paragraph one into the 1 paragraph one, you'd have to do a deletion. So here's the other third type of edit that diff knows about. So in order to make SUS3 and SUS4 equivalent, you'd have to delete the last 5 lines. Delete the last 5 lines, 5 to 9 of SUS3. SUS3 would have to lose lines 5 to 9 in a deletion. That is these lines right here. And what else? There's a difference in line 1 of both. Actually, there's more. In order to make this the same as this, you would have to change these 2 lines in SUS4 into the single line from SUS3. Actually, I have it backward. In order to make this the same as this, you gotta replace this in the left file with this in the right file. So the two lines, the one line in the origin file have to become two lines from the target file. And then this one means line 3 of the left file must be deleted. So that's how diff is going to interpret the differences between these two files. So that's more of a radical difference, much more radical difference between these two files here. Okay, so now we know the differences between files. So let's say you've got a couple of programs and they're 2 generations apart, or you made different versions of a program. Let me see if I can go to a directory where I know I've got versions of programs. Here's my scripts directory. Alright, so I got text to ping and text to ping get ups. So I know these two versions of this program do the basic thing, the same basic thing, except I'm using the get ops construct here in the second version. So if I look at the differences between those two, I'm going to see some extensive differences. So first is we see the difference at line 3 between text to ping and text to ping get ups. It's just a matter of the name, the comment block at the top on line 3. So there's a difference in the comment blocks on line 3. Also, there are differences between lines 5 and 7 in both. So on the left file, I've got this block, comment block. On the right file, I've got this comment block. And so on. Okay, so we've got more changes. Some spots I've got additions. That's an addition. More changes happening here. Additional changes between the two. Here's an addition. And I don't have any deletions actually for the last one, except one last one. Seems like just a blank line there for the last deletion. Okay. So that's what diff can do. And that has several uses. So one of them is by using the companion program, which is patch, the companion utility, which allows us to apply a diff file to an original. So once you've generated a diff, you can apply it with patch. And so it goes patch, some options, original file, and patch file. So this is the file you want to patch, and this is the list of patches from diff. So here we're going to generate a diff between SUS3 and SUS4. And I will save that or redirect it to a diff file called diff34. So if you look at it, let me go back to my previous directory, which was diff patch. I run the diff again between SUS3 and SUS4. Those are the differences. And then I will redirect to diff3 and 4. So diff34 is a diff file containing all this. diff34. So there it is, contains if the output from diff. now I'm going to save an original. Save SUS3 and give it the .orig. That is, I'm gonna make a backup of it and back up the original SUS3 since in case something goes wrong or in case I want to retain in case I want to retain the original. Okay, so now I've got the original. Now I'm going to apply the diff file using patch. I'm going to use the verbose option. This is the file I'm patching, SUS3. And this is the diff I'm going to apply to SUS3. So what should be happening is all those differences that make SUS3 different from SUS4, they're going to be applied to SUS3. And that should be the output. And what does it say? Interesting output. It says, looks like a normal diff to me. So it's looking at this and saying it's a normal diff output. And now it's saying it's going to patch file SUS3 using plan A. And it's going to tell me that several chunks succeeded at 1, 4, and 5. So these will be line numbers. What does it mean by chunks? The chunks are these chunks right here. So this is chunk 1, or this is chunk 1, and this is chunk 2, and this is chunk 3 in the diff file. So those are the 3 chunks. So as it applies each patch, each part of the patch, it's going to say it succeeded. So what's the result? If you look at SUS3 now, it should now be the exact same as SUS4. So SUS3 used to be 2 paragraphs, but it's not going to be 2 paragraphs anymore. So SUS3 and SUS4 are going to be the same. How do we know if they're the same? How can we tell if they're the same? Whether SUS3 and SUS4 are the same?
With the diff?
Yeah, we just verify using diff, yeah. SUS3 and SUS4 are now the same. There's no difference between the 2 files. After we did the patch right here. Okay, so what is good about that? Well, going back to Wikipedia again. Let me look at the history. How do you think Wikipedia stores its articles? Like, it has how many revisions does this? How far back does this go? 500 revisions or more. Going back to March of 2018, it's got to be older than that. Many revisions have gone by in this Wikipedia article. How are all the different revisions stored of these articles on Wikipedia? They're going to be stored as diffs, that is the differences. So look at any of these revisions. You can compare them versus previous version or the latest version or a newer version. Only the differences are being stored. And if you're only storing the differences for however many millions of articles there are, you're saving a lot of storage. So it's more storage efficient to do it that way, store differences only. Then it's much more efficient than storing entire new versions, entire versions. So you've got 1,000 versions, instead of storing 1,000 complete versions, you only have to store the differences between the versions. And then you just have to compute how one is different versus the other revision. So using diffs using a diff or storing the difference is a lot more space and also network efficient because you're transferring less data over the network. Comparatively fewer diffs versus entire files. This also works for like if you have, let's say, the Linux kernel, which is very large. So the Linux kernel, a single tarball, let's see. If you download the tar.gz archive, which is what the tarball refers to, it's like, I don't know, 100 meg, in excess of 100 megabytes, let's see. The tarball, it's compressed and it's 100 megabytes or more. So what do they make available? They make the patch available, or you can also view diff. Different patches, patch, incremental patch. So these patches are the differences between this version and the previous version, this version and previous version. So you only have to download the differences in the forms of these patches. These difference files are going to be much smaller than the entire thing. So using diff and systems like diff has a lot of many benefits. It gives you many benefits for both storage and network bandwidth. Revision control systems and utilities also take advantage of that, of systems like diff and patch. So when you use a version control system of some kind, you do that because, well, one, you want to keep track of versions of files. This is mostly helpful for when you're doing development of any kind, software development of any kind, but it can be used for other disciplines as well. All right. So revision control utilities, they will store the differences between versions of files rather than entire versions of files. So this is going to save space. So they can use Unix diff or something that has equivalent functionality. So you can use diff or something that has that functionality to play a part in defining the differences between versions of files. So this plays an important role in software development, particularly for distributed teams. Teams of developers that may be distributed, that is not all in one place. One such system is, this is very old, but this is a single user. There can be single user version control systems like RCS, revision control system. As it says, this is an early implementation of version control. This was designed to be used by a single developer, by one person. Later, let's see. Other version control systems that were actually meant for multi-user were developed, like CVS, also very old. The concurrent version system, it was actually a front end to RCS to make it multi-user. So that was also early and kind of old. Newer systems exist like Subversion, and of course Git, and also there are many others besides these, but these are probably the most well-known, Git and Mercurial. All right. These multi-user version control systems, they generally can be divided into centralized versus decentralized. So if you're using CVS or Subversion, you're probably not using CVS, but you might still be using Subversion somewhere. These are centralized. There's a central repository. Whereas if you're using Git or Mercurial, these are generally decentralized. Or you have, let's see, there can be a central repository, but it's a much more decentralized model. So Git and Mercurial. We're gonna do a Git exercise. Let's see, it's among the lab activities here. But just keep in mind that all of these version control systems, they are using their backend. You can say their backend or one of their pillars is some type of diff utility or diff command or diff system that stores the differences between versions of files. Okay, now we'll do some file utility exercises. And actually, I've already given the answers here. Let's go over some of this stuff. Right, so first task is I want to find all files that contain a string or regular expression. All files that contain string or regular expression. It says here, define a shell function called search files. You can also make this a shell script if you want. This is going to use the find utility to list all files that contain a string or regular expression. And you would pass it in as a first function parameter, $1. So with this, we don't want to search file names, or rather, we want to search the file contents for a string, and then list the files that match. So let's go here. I work in my examples directory for this. All right, so I got my examples directory. I've got these subdirectories under that. So I want to search for all files. They have to be files, not directories. So I'll say find starting the current directory, dot current directory. Find me all the regular files, type F. So I see all of that. So those are all the regular files I have under my examples directory. And within all that, I need the files that contain a certain string. So how would I do that? Suppose I can use exec for this. Find with the exec option, where I'm going to execute a grep. And just want to make it case insensitive to make it easier. So grep for something. Let's say butterfly. So here's these two things. The curly brace open and close, this means everything that find finds, all the files that find finds are gonna be, the names of those files will be substituted right here. And then I'll terminate that with semicolon with a backslash. Okay, so here are the results. What this is showing me is that I got two results from the grep. Okay, so this represents one file where butterfly was found, and this represents another file where butterfly was found. So let's see, how many files did find? There's actually 211. So the find utility found me 211 files. But of those, only 2 files contained butterfly, lowercase, or mixed case, or case insensitive grep. So actually what I need is I'm going to add another option to grep, which is L. This is handy because what L does is instead of showing me where in the file it matches, it's gonna tell me the name of the file where it matches. So those are the two files in which I have the word butterfly, case insensitive. And it's listing the names of the files, right? It's the grep with the -L. List option. So I've searched for, using this find, the string butterfly within my 211 files under examples. So here are the two files that match. So instead of using exec, you can always use xargs. So the xargs utility, it takes all the files that are found by find here. Those become arguments to xargs. So I'm gonna do a grep for lower case insensitive butterfly through all those files. This is gonna match, again, only the two files that contain butterfly. So that's an alternative to using that exec option with find. Sometimes you might want to do this. What I'm doing here is, okay, redirecting standard error to dev null, which means if there are any errors, actually there aren't. I don't have any errors here. This is all standard output. If there happen to be any errors, this means I don't want to see those errors. So I'm going to redirect it to dev null. But actually there aren't any errors. Another way I could have done that is, I'm going to search do a grep for butterfly again, where I'm going to list the files where it occurs. But for my argument, instead of a file name or something, I'm going to go do command substitution right here. So I kind of flipped that. So this means in that list of 211 files I get, this is going to give me a list of 211 files again. But I'm doing this in a command substitution, which means the names of those 211 files are going to wind up in a variable as a result of this. And I'm going to look through grep for the word butterfly through all that. So the same result, right? But with more recent versions of grep, you simply have to use the recurse option. So this is actually much easier. So recurse through all subdirectories, all files of all subdirectories using R. And do that same search for butterfly in the contents of the files. And you get the same result again. Oh, different format, since we don't see the / here because we're not using find. It just looks like that instead. So again, I list the two files where butterfly occurred. If I wanted to put that in the shell function, here's what it might look like. So function search files. So I have the different options that we can use with find. So here's the first way you could use find. Find with pipe to xargs here. Okay. Or I could also have chosen to do this instead with the command substitution around the find, or I could have just used modern grep with its recurse option. And let's see. Except, of course, this is a function. This is now done inside a function called search files, which means I'm going to use the positional parameter $1 right here. So if I define this function in the current shell, function search files. Okay, so I've defined it in the current shell. Now I have a search files function. I can search for butterfly here. Butterfly. So now this butterfly becomes the argument to the function. Will get substituted wherever I have $1. And there's my output. $1 here. The reason why this is quoted, double quoted, is because in case I have like
Something with spaces.
yeah, if you want to have the butterfly, okay. In order to make this a single argument, I have to put double quotes around it. So the double quoted argument here becomes $1, and I still need to have the double quotes around this. Otherwise, it's gonna think that only the is the argument. In that case, it doesn't work. The butterfly. I wonder why. Oh, it's the lone monarch butterfly. The lone monarch butterfly flew flutteringly. So maybe if I can use a regular expression here, the butterfly with 0 or more of any character in between. Now it works. You can also use a regular expression here with this. Between the and butterfly, 0 or more of any character will also work. It's gonna find me my 2 files. So you can create the search files function that can be defined in the current shell, or you can actually make it a shell script as well if needed. What about this? All right. Here I want to create a function that's gonna change to a directory based on a find result, which might be useful. So I want to define a shell function called find cd that changes to a directory based on a find result. So if both searches and changes to a matching directory, where a file name of the match exists. So you're searching for matches of a file name. Then you want to change to that directory where the file resides. And if what you're searching for matches a directory name, then you'll change to that directory. So here I want to find cd to a random wall. So if there's a file, if there's a directory called random wall, or a directory that contains a file called random wall, then I'll change to that directory. Or examples, find cd examples. It'll change to the first directory named examples. Or if here I want to change to a directory that contains a file called roster, then I'll just go find cd roster. Note that this has to be a function and not a shell script. Or this should be a function and not a shell script, because again, shell scripts run in their own subshells, and this is a function that's meant to change to a directory. Changing to a directory in a subshell is kind of meaningless, interactively speaking. If you're interactive, changing to a directory in a subshell isn't going to do anything. Like, change to the temp directory in a subshell here. I'm forcing the cd to the temp directory in a subshell by putting parentheses around it. Okay, so it happened. I changed to the temp directory, but as soon as I exited the subshell, I'm back in my original directory. which is why this has to be a shell function. Okay, so let's see how we're gonna do this. I'm gonna break this down. Find result is equal to result of a command substitution, where the command substitution contains this pipeline. We're going find from the current directory case insensitive search for a file name or directory name that matches this. And give me only the first result. So here in my I'm going to start in my SE-370 directory. I'm going to do a find. And I'm going to do a case insensitive name search for anything that contains sed. This is not a regular expression, by the way. This is just file globbing. Find me something that contains the word sed lowercase, or any case. So there they are, right there. So these are the find results for everything that contains sed. Unfortunately, it matches this, SED, right? It matches that. It also matches case demo sed, also matches sed and such. Okay, so that's the first part of that. And then we're only interested in the first hit. So that means I want to call the head function and this is gonna give me only the first hit. So reduce it to just the first slide. So which is gonna be this one right here. That's the first find result. I only need the first find result. So that's what this is gonna contain. I'm gonna assign it to find result. Okay, so this is a command substitution, which gives me one file name or one directory name. I assign it to find result. I can do that here as well. By putting this in, let me try a different one. Let's try awk instead. Okay, so here is examples text awk. So by putting command substitution parentheses around that, I'm going to store this find result and find result. Find result, not find result. Find result. So the find result variable, the find result variable contains this right here. And let's see what happens after that. Actually, let's go back here. Note the comment here, use head instead of tail. So there, you can use either head or tail here, but I chose to use head because otherwise you may have to wait for find to print many search results. So if you're using tail there, you'd have to wait until the very last line of find occurs, and then you would do a tail. Using the head here means you're just going to take the very first find result, so it'll be faster. Also, if find finds nothing, if the find is not successful, then this variable will be blank, find result. The next part is we want to see if that's a file. If find result is a file, then we cannot actually change to it. You can't CD to a file. You can only CD to directories. So you have to trim the find result so that it's only a directory. So that's the second part of this. So we're checking here with this test, a file system test with a -f. Is it a file? Is the find result a regular file? And if that is true, we're going to use the base name on that file name. So base name, let's see what that does. I'll look for fiction this time. So if I'm searching for the file name that contains the word fiction, so there it is. All right, so the first hit is examples text said fiction dot indented. Obviously, I cannot CD to that. That's an error. You can't CD to a file name. But if I do a base name on the find result, what happens? Okay, if I do a base name on the variable find result, I get only the last part of it, as you can see right here. So that's what find result contains. That is a full, not a full path. It contains the path to fiction.indented. When you apply the base name command to that variable, you get only the file name at the end. You get fiction.indented. And then what we'll do is we're going to save that to, assign that to file name, another variable file name, using command substitution again. So the file name is now fiction.indented. And what I'll do is I'm going to delete the file name from the end of the find result so that it's now a directory name. Okay, and that's going to be done using this pipeline. So again, so I'm going to echo the find result. Let's echo the find result first. So that's the find result. The full path name, the full path to fiction.indented. And then what I'll do with that is I'm going to do a sed, searching for the file name in here. So I'm searching for fiction.indented, which is file name, at the end of that. So the dollar here is the dollar here means the end of the input. And I'm going to delete it. So the result is, that's the result. So it's find result minus the last part, which is fiction.indented. So I see only this. Only up to examples, text set. And that I can CD to. I can change to that just fine. If I use command substitution. Okay, so this command substitution is going to give me a directory name, where the file is located, and I'm going to be able to CD to that. So I end up CD changing directory to SE-370 examples text set. So I assign it to another variable find result, and I'm able to CD to the find result. And if at the end the find result is also blank, then nothing will happen as a result. So let's try adding this function to the current shell environment and test it a few times. Let's do that again. Okay, so I'm gonna define it here in the shell. I have a find CD function now. So I'll find CD and I'll look for awk. So this means change to the first directory that contains either file or directory called awk. All right, so there it is. Find CD awk. So it takes me to examples text awk. In that case, it just found the directory name that contains awk. So I find myself in there. Also try that with fiction. Find CD for fiction. I'll change the directory, a subdirectory under SE-370 that contains a directory called fiction or some file that contains the word fiction. So I find myself in, I've changed to SE-370 examples text said, where there's a file called fiction and also fiction.indented. And so that's how this find CD function is going to work. Okay, this function is going to depend on the property of the find function. The find function by default it wants to do recursion. So if you're looking for something using find at a particular directory, and that particular directory has subdirectories, it's going to recurse into those subdirectories. So it would not work without find here. The find CD function. Let's see. We have another third. I want to find the maximum directory depth. So within your home directory, find the maximum depth of a directory, and your results should include the directory's name. All right, so again, this is gonna depend on find, and it's just gonna require using the printf option. So this one is not a function, we're just gonna use a find function. So let's see. Let's see what this means, the printf function for find. Okay, the printf function. What does it do? So you're directing find to print its find result in a specific format with printf. You could also use print, but how printf differs from print is that it does not add a new line at the end of a string. So what we're doing here is starting the current directory, which is the dot. So find dot. I want to find only directories. So this time we're specifying that we're only interested in the directory type D, only directories. And then print the depth of each directory found. That is this variable here, $D, or is that %D? Should be %D. So let's try that find command, just like this. So this is going to print the depth of each directory found. for each directory. For this, I'll start at CS-370. Just CS-370. No, that's not it. Okay, so starting the current directory CS-370, look for only directories and print only the depth of each directory. So this is the actual output here. If I was not using that, okay, this is what I would be getting. So it finds all the directories. If you're only doing this, okay. So it's finding the current directory. That has a depth of 0. Current directory, depth of 0. Projects directory has a depth of 1, because it's only a direct subdirectory of this directory. Projects 1 dash text to PDF has a depth of 2, because it's two subdirectories down from here, from the current directory, and so on. Okay. Projects 3 names to user IDs also has a depth of 2. And then direct subdirectory scripts has a depth of only 1. So that's what these numbers are about, the depths of the directories. So that's what we see when we use this. Okay, we're just getting a bunch of integers back, which are the depths of the directories that it finds. Now we're going to also print the path of each directory found by using print. So I'm going to add a dash print to that command, so that we get not only the depth of the directory, but also the name of the directory itself with that depth. Okay, so that's the print. Now we're going to do, since we have 2 columns of output, where the first column is an integer, numeric integer, we're able to do a sort. We're going to be able to sort that numerically. We want numeric sort, since we're sorting the first column. And we want to do that in reverse, because we want the larger numbers up top. So that's what we end up with. Larger numbers, larger depths up top. And since we are only interested in the first find result, that is the maximum depth and the directory's name, we're going to, again, give me only the top of the output with the head dash n1. Give me only the first line of output from the sort. So there it is. For me, it is, the depth is 5, and this is the name of the directory right here. All right. If you wanted to do it that way, you could also do exec, find with an exec option. So find with the dot, same as before until you get to here. Now we're doing exec. And we're doing an ls-ld on each find result. So let's see what that gives me. The LD option for ls, what is that? Doesn't exist. LD option, it's a directory. So this directories themselves, not their contents, it says. Okay, so slightly different approach using find again, but still using, let's see, I want find to give me the depth of each directory it finds. But I also want find to do an ls-ld on each find result here. Single quoted semicolon is the same as going backslash semicolon. Okay, so there it is. So it's giving me the depth of the depth again of each directory it finds, as well as the name of each directory. Then again, I can just sort, reverse numeric sort, and then just use the head command to give me only the first line of output from that. Okay, so that's two different uses of find there. And this is one of those many find options that are available. This time we're using, let's see, this particular code, the %d means the depth of the directory. All right, so those are some find utility exercises. Now let's try our Git repository exercise. And note that this is going to actually count towards your participation grade. So you should do this one. So we're going to be using our GitLab, the GitLab installation at CSSC Git, which you have already used. So you should log in here first. Secondly, you should set up Secure Shell login to GitLab. So you should have already created a Secure Shell private public key pair in week 1. So this is something we haven't done. There's a shell script here that you can use to check your Secure Shell key setup. Although it might be a little hesitant to actually run that. Although it probably won't hurt. Let's see. So that shell script is this right here. So we can look at what it does. So it just consists of some file system tests. So what is this checking? This means not directory. No directory called .ssh in your home directory. So it's saying, it's checking for the non-existence of a .ssh directory. If you do have Secure Shell keys, that directory exists. If you generated keys, you should already have that. We're just checking for the non-existence of that directory here. And if it doesn't exist, you're gonna see this output that it wasn't found, that directory was not found, so this is going to actually create it for you. And it's also going to run the keygen command to generate the SSH keys. So it's going to create that directory like this, and then it's going to run SSH keygen. So that'll give you keys if you haven't already created those keys. So if I ran this if statement, just that if block here in my current shell, nothing should happen because I already got that. Okay, yeah, nothing should happen. Although something did happen, which is not good.
So are we gonna be okay if we do this after class? Because my SS keys are a bit messed up right now.
Yeah, let's see. Okay, and if you do have a Secure Shell .ssh directory, but you do not have the files. So you may have a directory .ssh, but you may not have the actual key files that have these names. So this is checking for the existence of regular files that have these names, or non-existence, since we're using the exclamation. So if this file doesn't exist, or this file doesn't exist, then it's going to say no SSH keys found in that directory. And again, it's going to run Secure Shell keygen to generate the keys. Another thing it's gonna check it's gonna check if you do not have the authorized keys file here. If that file does not exist, the authorized keys file is not found, so it's gonna say that no.ssh authorized keys found. Now it's gonna copy the public key to the authorized keys file using CP right here. And here finally, if that file does actually exist, or actually here, if the contents of your public key are not in your authorized keys file using a grep. So it's going to look inside your public key file. If it does not exist in authorized keys using grep. This is a conditional chain, which means if the first part does not succeed, you will do the second part here using a conditional chain. And what that will do is it's going to append the contents of your public key to the end of authorized keys using redirection. That's what this shell script would do. If you do have secure shell keys already set up, what you need to do is after you log into GitLab, go here, edit your profile. Okay, so upper right corner, edit your profile. On the left, under user settings, you've got secure shell keys. This is where you're gonna paste in your public key, the contents of your public key, which I probably already have, but all right. So what you need to do is, let's see. In your .ssh directory, this might work better. There should be this file right here. So that's the public key file. ID underscore RSA.pub. That file. You can cat it. So that's your public key. That's what gets uploaded or copied to highlight, copy back to your profile on GitLab, paste it there like that. You're adding an SSH key in, but actually what you're adding is the public key only. Private key doesn't go here, only the public key. The contents of the file, and then you add the key right here. None of that's, I don't think you have to change any of this, just have to add the key. Okay, and with that, you're able to, you've added a key, now you're able to do Git operations from your Unix account. Okay, what you need to do next is, so after that, we've done that. We're gonna make a backup of your course directory, CS-370 or SE-370, using either copy or rsync. If you're using copy, you'd be using this command. Let's understand what this does. So copy with archive, the archive option, which means it's going to copy all subdirectories under CS-370. This is verbose. It's going to copy verbosely. The copy it makes will be named, let's say, CS-370 dash current date and month, day, and year. Dash will be followed by month, day, year. So this is a command substitution that's done in line with a file name. So the date command, if I echo this, if I just echo it, that's what it looks like. Okay, so CS-370 dash followed by the output of date, month, day, year. That's the name of that's the copied subdirectory's name. So you can go cp-av CS-370. Or just copy from the web page. Month, day, and year. If you ran that, it's gonna create a copy. Gonna archive your subdirectory, your course directory, and it's gonna be backed up. Okay, or you can also equivalently use rsync to do the same thing. Okay, so once you've done that, you have a backup of your course directory. You can then go back to GitLab and create a new project on GitLab. Let's do that. Okay, there should be a new project button right here. If you can't get there, just click on this dashboard thing on the upper left. It'll take you to your existing projects, then you click on new project right here. You're going to be creating a blank project for this. Blank project. Give it a project name, CS-370. Okay, semester, SE-23, let's say. That's your project name. Your project visibility should be private. Available only to you or other members that you assign to it, so it's private. And okay, okay, we're gonna choose to have a README file, so we'll just keep that. And then you can create project. Oh wait, there's one more thing. Group or namespace where you want to create this project. So this would be, just choose your user, users, your user, and create project.
I don't think we have that choice.
You don't?
Mine just defaults to the user CSC get monolith.edu with the username.
Okay.
It's like I think we probably have something more complicated going on.
I should try logging in as my student user instead. I'll do that.
Which for the group size?
No, with where he's changing his username.
Let me log out.
We have group set up and we don't have group set up, so.
I'm going to sign out and log back in as my student ID.
From a previous class.
Oh, sorry.
841.
Same thing, but I'm gonna use this
Okay.
All right.
Yeah, I guess it depends on if you have a class that uses it.
I'll do it here instead. So here my student account, create blank project.
Yes, that's what I see.
Yeah, CS-370 summer 23. Yeah, it's already set up to look like this. Private, README, and create project. So here you are. Okay, so you've got a new project now, or a new repository. And let's follow these directions. All right. So it's a private project. We're gonna follow the instructions on GitLab to git initialize or git init your Unix account course directory, and then eventually you get to the point where we can push the contents to CSS to GitLab. So
This is where I get confused, because it says cd existing repo.
yeah,
You need to be in the directory below where the repo exists, or do you need to be in the repo that you see the confusion? They just say CD existing repo. So in this case, would we be in the CS-370 -date directory, or would it be one subdirectory below it?
You'd want to be in your course directory. Hold on, let me try this first. So CD existing repo. So I'm going to be in, let's see, CS-370. Maybe I should make a backup first. I haven't made a backup.
Here, I'll try mine.
In my case, I gotta use copy
Don't you get
SE-23.
init first?
23. Month, day, year. Okay, so I have a backup. So now I'm gonna be in my CS-370 directory. So this is my 370 directory right here. So it says git remote add origin. Go back. Just copy that. Git remote add origin and then the URL given right here. So I'm in my CS-370 directory.
See, I got that too. Don't we have to init first?
Usually, but I'm not sure why this isn't, I mean, it's blank.
This probably presumes that you've already done it. That's why I get confused. Getting it, you do just once, right? You don't do for each project?
Yes, you should only do once. It should be git init. Where's the git init?
And that's where I really get frustrated on the command line, because do you get it in your home directory or in the project directory?
Sorry. Push an existing Git repository. So this only applies to existing Git repositories, which
Right.
we don't have yet. So you want to upload files? Or do we want to create files?
But that's gonna be individual
This is a
files.
shame.
You need to create a repo.
Add a file to repository alters for the upload. Because something's changed. The directions there for new projects used to contain the steps, including git init, but they don't any longer. The documentation has degraded to something not
Because
useful.
you have to do git init, I'm looking it up, I'm remembering, git init, git add, and git commit
Test
on
and
the local repo before you can put it anywhere else.
What the hell? So they changed the default documentation to make it less useful. So then, let's do that then. Let's follow these directions. So git init. So I use git init first. And then you have this initialize empty git repository here. Okay, so first do git init. This is missing from the instructions. And then that initial commit is also missing. Isn't it? So please run git init first in your course directory.
Wait, the original course directory or the cloned course directory?
Original, since you're, well, okay. Your choice.
Okay, it's the same difference, but
Yeah, it's your choice.
depending on whether you want us to keep updating it or not.
Okay, so from there, I think we might be able to proceed from here. After we've done the git init, then we can run the git remote add. Okay. That's normal. Seems like nothing happened, but that's normal. Then we can git branch main. Again, it looks like it doesn't do anything, but that's normal.
So I got error ref name, fatal, branch name, branch rename.
Then we can try this git push, which may or may not work. Failed to push some refs too, because we did not do the original. We didn't do the initial commit, did we? Origin name.
Right, because you have to git commit before you can do anything else.
Yeah. Let's try our git commit then. With the comment initial commit.
Yeah, I got the same thing.
So after your git commit,
I don't think that worked. Because you have to specify, because right now I'm getting a list in initial commit, nothing, untracked
yeah,
files,
git add.
everything.
Okay. Git add period.
Yeah.
This may not be the correct order, but we're gonna do git add period. Git add period.
Now commit should work.
Then do commit. Again, git commit, initial commit.
It worked for me.
Yeah, I don't know why you failed adding files.
I'm good.
Possibly because, wait, did yours fail?
No, I meant for that. It worked for me.
It worked for me.
Works for you.
But you're
Maybe
on, you've got that weird file structure, right? Because you're on your
no,
Apple account.
because it's failing on one of Paul's files for whatever reason. It's because I have an error when that happens. Yours may not have the same error. Oh, because it has weird permissions. Why does it have such weird permissions? I'll simply, for now, I'm just gonna delete it. I believe this only applies to me. I'm not sure that's gonna work. Okay. So then, now I can probably do this. So git add everything. Starting from the current directory, add everything. Then I can do a git commit. The initial commit, this should work now. That's what I should see. After the git commit, and then do the push. This is asking me for a password.
Yeah, me too. And then it really got weird.
But it is pushing right now for me. So it is now pushing. Although now it's saying error. Failed to push. Protected branch of this project. Okay. It's probably because of this. Okay, so some of this works. Let's see. Looks like the push failed. Okay.
Looks like.
Redirect me, redirect me, redirect. Oh, I'm not liking this at all. Right, so okay. Previous versions of GitLab did have working instructions. This version of GitLab, not so much. So I'm gonna have to write out the actual working directions, and then I'll add them here. I should add them right here, because these instructions apparently don't actually work. Just dumb. Okay, so I will fix that. Let me fix that, and I will get that uploaded. I'll get this page updated, or this part of it anyway. Instructions for GitLab to actually successfully push the contents of your course directory. What you can do in the meantime is add me as a member of your GitLab project, and the member type should be reporter. So what that means is, go back here. Okay, so here for this project, for the project you just created, under settings, or not settings, project information rather. Project information on the left, members. Should right now the only thing you should see is yourself. You're going to invite members. Click invite members. You're going to search for username Jay Chung. You should find me right there. Select the role. It's not a developer but a reporter. Optional expiration date, and then invite. Okay, so you should see that now. It'll be you and also me as a reporter only on this project. So that's where we'll leave that as far as we can get right now for this right here. All right, so then got your assignment due, that's tomorrow. Assignment due tomorrow, and I'll be posting the project 2 since we need to get started actually on project 2. And then we have a quiz on Thursday. So that'll be the second quiz, and there's supposed to also be a final according to syllabus, which I need to update. So it looks like there's only going to be 2 quizzes here, and then there'll be a final exam. So the last exam will be that final exam.
Take home this one?
I'm considering it, yeah.
What is our last day of class? Because I think it gets on July 3rd officially.
Is it? Let's look at the calendar.
Have you used some?
Do I have the calendar?
and I have no idea how they do final exam schedules in the summer period.
I don't think I would already have this in my funny that. Academic calendar, summer 2023, summer B. Classes end July 3rd. Final exam will be that date, July 3rd. If it's a take home, then it'll be the weekend of July 3rd. Right? Okay. And instead of taking a final exam on July 3rd, we'll actually show up here and finalize the final project. Okay.
Sorry, what?
Instead of taking the exam on July, if I give you a take-home final, instead of coming and taking the final on Monday, July 3rd, you'll present your final project on July 3rd.
I'm not gonna be here July 3rd.
Oh, that's right.
Yeah.
It's kinda like a holiday, basically.
Yeah.
It's not officially a holiday, but the way it hits.
Anyway, so that's when the final project will actually be due, at the end of Monday, July 3rd. Right? So we can use that day to finish working on the project. If you need to be here to do that, we can do that. To finish working on the last project. Okay, so I'm gonna decide that, and I'll tell you what the format of the final will be, whether it'll be take home or in person.
But either way, the third project will be due on that day.
Yes, not third project, second project.
Sorry, no,
There's only gonna be a second project.
oh, you're right. Never mind.
Yeah.